Outside plant cable is not required when running cables from a plenum ceiling down a wall through the slab and to a floor-mounted box, provided that regular Plenum UTP cable is used. Let's review some NEC requirements. NEC Section 800.110 states that plenum cables are permitted to be installed in other spaces that are not plenums, such as risers and vertical shafts. NEC Section 800.179 states that communications cables within a plenum must be listed as plenum cables or be installed in metal raceways. NFPA 90A, which is the standard for air conditioning and ventilating systems, Section 4.3.10.4 says that plenum cables are permitted to be installed within plenums. The NEC definition of plenum, Section 300.2c, defines a plenum as a compartment or chamber that forms part of the air distribution system of the building. Therefore, since the cable is routed through a wall and under slab, it is not considered to be within a plenum space. Regular Plenum UTP cable can be used without the need for outside plant cable. Understanding the relevant codes and definitions is key to ensuring compliant and safe cable installations. Firstly, let's clarify the purpose of plenum-rated cables and where they are typically required. Plenum spaces, as defined by the National Electrical Code, are compartments or chambers that form part of the air distribution system of a building. These spaces are often found above suspended ceilings or under raised floors and are used to circulate air for heating, ventilation, and air conditioning systems. Because these plenums can distribute air throughout the building, it is crucial to use materials that do not produce excessive smoke or toxic fumes when exposed to fire. Plenum-rated cables are specifically designed to meet these requirements. These cables are constructed with materials that have low smoke and low flame characteristics, which means they produce minimal smoke and do not readily propagate fire. This helps to maintain visibility and reduce the risk of toxic gas exposure during a fire, allowing occupants more time to evacuate safely. Secondly, let's consider the use of outside plant or OSP cables. OSP cables are designed for outdoor use and are built to withstand harsh environmental conditions such as exposure to sunlight, moisture, and temperature extremes. These cables often have robust jackets and shielding to protect against physical damage and interference. However, OSP cables are generally not designed for use in plenum spaces because they may not meet the stringent smoke and flame requirements. The NEC provides guidelines for the types of cables that are permitted in different areas of a building. As mentioned earlier, Section 800.110 allows plenum cables to be installed in non-plenum spaces, such as risers and vertical shafts. This means that if you are running cable from a plenum ceiling down a wall, you can continue to use plenum-rated cable even if the wall cavity is not considered a plenum. Section 800.179 reinforces the requirement that cables within a plenum must be either plenum-rated or installed in metal raceways. This provision ensures that only suitable materials are used in plenum spaces to minimize the risk of fire and smoke propagation. NFPA 90A, which is the standard for the installation of air conditioning and ventilating systems, also addresses the use of cables in plenums. Section 4.3.10.4 specifically allows the use of plenum cables within plenums, aligning with the NEC requirements. Thirdly, let's address the specific scenario of running cables through a slab. When cables are routed through a wall and under slab to a floor-mounted box, the section of cable running through the slab is generally not considered to be within a plenum space. This is because the slab is a structural element and not part of the air distribution system. In this case, regular Plenum UTP cable can be used without the need for OSP cable. However, it is important to ensure that the cable is adequately protected from physical damage and moisture when running it under slab. Conduit is often used to provide this protection. Conduit is a rigid or flexible tube used to enclose and protect electrical cables. It can be made of metal or non-metallic materials and is available in various sizes and types to suit different applications. When running cables under slab, it is recommended to use conduit to prevent damage from moisture, chemicals, and physical stress. The NEC provides guidelines for the installation of conduit, including requirements for support, spacing, and grounding. It is important to follow these guidelines to ensure that the conduit system is properly installed and functions as intended. Consider the type of environment the under-slab conduit will be in. If the environment is prone to moisture, then consider using a watertight conduit and fittings. Furthermore, different types of conduit are suitable for different applications. For example, rigid metal conduit, or RMC, is a heavy-duty option that provides excellent protection against physical damage. Electrical metallic tubing, or IMT, is a lighter weight option that is suitable for use in dry locations. Non-metallic conduit, such as PVC, is resistant to corrosion and is often used in underground applications. Fourthly, let's discuss the importance of proper cable management. Regardless of the type of cable used, proper cable management is essential for ensuring reliable performance and ease of maintenance. This includes properly supporting and securing cables, avoiding sharp bends or kinks, and clearly labeling cables for identification. Cable ties, straps, and trays can be used to organize and support cables, while labels can help to quickly identify cable runs and termination points. Proper cable management not only improves the appearance of the installation, but also reduces the risk of damage and interference. Additionally, it is important to consider the bend radius of the cable when making turns. Exceeding the minimum bend radius can damage the cable and degrade its performance. The cable manufacturer typically specifies the minimum bend radius for a particular cable type. When installing cables, it is important to avoid pulling them too tightly. Excessive tension can damage the conductors or insulation, leading to performance problems or even cable failure. The pulling force should be within the manufacturer's recommended limits. Fifthly, let's examine the considerations for grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers or fuses, to trip and de-energize the circuit. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding. These requirements vary depending on the type of system and the location of the equipment. It is important to follow these requirements to ensure a safe and reliable electrical installation. When running cables and conduit, the conduit itself should be properly grounded and bonded. This can be achieved by using grounding bushings or connectors that provide a secure connection to the grounding electrode system. In addition, any metal boxes or enclosures that the cables terminate in should also be grounded and bonded. Furthermore, the choice of cable type can also impact grounding and bonding requirements. For example, shielded cables may require special grounding techniques to minimize noise and interference. The cable manufacturer's recommendations should be followed when grounding and bonding shielded cables. Sixthly, consider the specific requirements for UTP, or unshielded twisted pair, cables. UTP cables are commonly used for data communications and are available in various categories, such as Category 5A, Category 6, and Category 6A. These cables consist of twisted pairs of wires that are used to transmit data signals. The twisting of the wires helps to reduce interference and improve signal quality. When installing UTP cables, it is important to follow the manufacturer's recommendations for cable length, bend radius, and termination techniques. Exceeding the maximum cable length can degrade the signal and reduce data transmission speeds. Similarly, improper termination can introduce noise and interference. UTP cables should be terminated using connectors that are compatible with the cable category. For example, Category 6 cables should be terminated using Category 6 connectors to ensure optimal performance. In addition, it is important to avoid untwisting the wire pairs too much when terminating UTP cables. Excessive untwisting can increase interference and reduce signal quality. Seventhly, let's explore the importance of documentation and labeling. Proper documentation and labeling are essential for maintaining a well-organized and easily serviceable cable installation. Documentation should include detailed drawings or diagrams showing the cable routes, termination points, and equipment locations. This information can be invaluable when troubleshooting problems or making future modifications to the system. Labels should be used to identify cables, connectors, and equipment. Labels should be clear, durable, and easy to read. They should include information such as the cable type, destination, and circuit number. Labels can be printed using a label maker or handwritten using a permanent marker. It is important to place labels in a consistent and logical manner so that they can be easily located and understood. Eighthly, when selecting cables and components, ensure that they are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all. Listing and labeling indicate that the products have been tested and meet applicable safety standards. This provides assurance that the products are safe to use and will perform as intended. Look for the UL mark or other recognized testing laboratory mark on the cables, connectors, and conduit. This mark indicates that the products have been certified by the testing laboratory. Ninthly, let's address the issue of fire stopping. Fire stopping is the process of sealing openings in walls and floors to prevent the spread of fire and smoke. When running cables through walls or floors, it is important to ensure that the openings are properly fire stopped. The NEC requires that fire-stopping materials be listed for the specific type of construction and penetration. Fire-stopping materials are available in various forms, such as sealants, foams, and wraps. These materials are designed to expand when exposed to heat, creating a barrier that prevents the passage of fire and smoke. It is important to follow the manufacturer's instructions when installing fire-stopping materials to ensure that they are properly installed and will perform as intended. Tenthly, consider the use of low-voltage cables. Low-voltage cables are often used for powering and controlling various types of equipment, such as lighting, security systems, and audiovisual systems. These cables typically operate at voltages of 50 volts or less. The NEC provides specific requirements for the installation of low-voltage cables. These requirements address issues such as cable routing, support, and protection. Low-voltage cables should be separated from power cables to minimize interference. They should also be properly supported and protected from physical damage. In summary, when running cables from a plenum ceiling down a wall through the slab into a floor-mounted box, regular Plenum UTP cable can be used without the need for OSB cable, provided that the cable is not exposed to outdoor conditions and is properly protected from physical damage and moisture. It is important to follow the NEC and NFPA requirements, use appropriate cable management techniques, and ensure proper grounding and bonding to ensure safe and reliable installation. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns about cable installations. They can provide guidance on the specific requirements for your application and help you ensure that the installation meets all applicable codes and standards. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. By following best practices and adhering to the relevant codes and standards, you can ensure that your cable installations are safe, reliable, and compliant.